am Dr.B.Krishnaveni, Assistant Professor, Mathematics Department, Aditya University. Today we are discussing about double integrals over regions. So, if the limits are not given and the given region of integration, how to evaluate the double integration? So, that is at the end of this lecture, student will be able to evaluate double integrals when the region is given. That means without limits, but we know the region of integration. By using that region, we need to find out the limits according to the question and we need to evaluate the double integration. So, that is the learning outcome of the today lecture. So, let us see how to evaluate the double integrals over the regions. So, here let me explain this by taking some random region of integration, and here this is the figure. In this, the dotted area representing the region of integration. So, in this region, we need to evaluate the double integration. That means we need to cover this area which is in the dotted region. So, to do this, there were two cases. The first case is, or you can say the two methods. The first method is we can consider horizontal strip which is parallel to x-axis, or else you can consider a vertical strip which is parallel to y-axis. By taking any of this strip, you can find out the double integration and both are same obviously. So, now let us start. This is the region of integration represented as dotted area. So, now let me explain how to evaluate double integration if we consider horizontal strip in the region of integration. Horizontal strip means it is a strip drawn which is parallel to x-axis. In this region, how to find out the limits? So, whenever we have taken a horizontal strip, first we will calculate x limits from left to right along the strip. So, that means whenever we have taken a horizontal strip, first we need to find out x limits along the strip from left to right. Do integration with respect to x, then you are able to find out the area of the strip. Thereafter, we will find out y limits along a y-axis in the region of integration. If you do this, then we will get this strip and integrating with respect to y here, this strip will travel from this point to this point, so that we can cover this entire region of integration. So, this is the way to find out the double integration if we consider horizontal strip. So, now let us take the same region of integration and let us evaluate the double integration using vertical strip. So, let us draw a vertical strip. This is a vertical strip which is parallel to y-axis. So, now in this case, first we will able to calculate y limits along the strip from bottom to top. So, that means we need to consider y limits along this strip from bottom to top, and integrating with respect to y means you can find out the area of this strip. Thereafter, we will calculate x limits along x-axis in region of integration. That means in this region, we will calculate the x limits along x-axis from this point to this point, which representing the region of integration. So, now if we integrate this with respect to x between these limits, so that this strip will travel from this point to this point, so that it covers the entire region of integration. So, this is the way to follow to find out the double integration over region, either by taking horizontal strip or else vertical strip. So, let me illustrate the same using examples. Take out the first question. That is, the question is evaluate double integral over r y dx dy, where r is the region bounded by parabolas. The one is y square is equal to 4x, the other is x square is equal to 5y. So, now see, this is the parabolas, and you all know that one is you can draw the parabolas. Y square is equal to 4x, which is symmetrical to x-axis, x square is equal to 4y, which is symmetrical to y-axis, and the region bounded by these two curves is the dotted area, which is shown in figure. So, now let us find out points of intersection. For that, we need to substitute one equation to the another equation. So, if we substitute here y is equal to x square by 4, if we take the second equation x square is equal to 4y, From that y is equal to x square by 4. Substitute this in equation number 1. Then the equation number 1 becomes y square it is, that is x square by 4 whole square is equal to 4x, which gives x power 4 is equal to 64x. On simplification you got x is equal to 0, x is equal to 4. Now find out the corresponding y values. So x0 means y0, x4 means y4. Hence the points of intersection is given by 0, 0 and 4, 4. Let us represent with OE. So that means here this on the figure these two are representing point of intersection. The one is 0, 0. Here the other is 4, 4. And the shaded area between the parabolas 1 and 2 gives the region of integration. So now to evaluate the integration within the region of integration. So here we need to consider either vertical strip or horizontal strip. So in this question we are getting y limits means they have taken vertical strip. So now let us see how to find the limits. Here let us consider vertical strip. So vertical strip means first we will get y limits along the strip from bottom to top. So bottom is touching which curve it is, x square is equal to 4y, from that y is equal to x square by 4 to up. Up is touching the curve y square is equal to 4x, that means y is equal to root 4x, which gives root 2 root x. This gives the y limits. So now come to the x limits. In order to find out the x limits, so here it is a 4, 4, the corresponding point is 4, 0. And here the point is 0, 4. Now need to take x limits along x axis in the region of integration, means that from this point to this point, here it is 0, 0, that means x is from 0 to 4. So y limits are from x square by 4 to 2 root x, x limits are from x is equal to 0 to 4. So hence our given integration double integral over r y dx dy can be written as x is equal to 0 to 4, x limits, here it is, and y limits x square by 4 to 2 root x, y dx dy. But here y limits are variable limits. So that's what first with respect to y we have to do the integration, thereafter with respect to x. So now what y integration is, y square by 2 between y limits is equal to, you can take 1 by 2 outside the integration which is constant, integral 0 to 4, substitute the upper limit 2 root x, that is 2 root x whole square means 4x, minus the lower limit x square by 4, that is x square by 4 whole square means x square by, so total we are getting x power 4 by 16 dx. So now do integration with respect to x, 1 by 2, 4 into x square by 2, that is 2x square, minus x power 4 integration is x power 5 by 5, 5 into 2 is 16, limits of x are 0 to 4. Substitute upper limit x is equal to 4, lower limit x is equal to 0 means 0, then we got the answer is equal to 48 by 5. So this is the question which we evaluated the double integration by taking vertical strip. So now the next question is, evaluate double integral over r y dx dy, where r is the domain bounded by y axis, the curve y is equal to x square and the line x plus y is equal to 2 in the first quadrant. So the one is parabola and the line, and we need to take the region of integration in the first quadrant only. So the one is y is equal to x square, the parabola it is. The other is the line x plus y is equal to 2, this is the line which intersect at 2, 0 on x axis and 0, 2 along y axis. So now let us find the points of intersection. So given curves y axis means x is equal to 0, the second y is equal to x square and the line x plus y is equal to 2. So now use these two equations, substituting y is equal to x square in the third equation, you got the equation as x square plus x minus 2 is equal to 0. And finding the factors that the roots of this equation are x is equal to 1 and x is equal to minus 2. And the corresponding y values, x is equal to 1 means y is equal to 1, x is equal to minus 2 means, and hence therefore what are the points of intersection are? This gives the points of intersection. So now let us evaluate this again by taking vertical strip. So if you consider the vertical strip in the region of integration, then First, we will need to find out y limits along the strip from bottom to top. So, bottom is touching y is equal to x square, so the lower limit. Up is touching the curve x plus y is equal to 2. From that, what y is equal to 2 minus x. Now, what about x limits? Should take in the region of integration from this point to this point. So, here it is 0, 0 and 1 means here it is 1, 0. The x varies from 0 to 1. So, now again, since we have taken vertical strip, the order must be first with respect to y, thereafter with respect to x. So, let us do integration with respect to y first. So, y integration is y square by 2 between the limits x square to 2 minus x. Then, substituting upper limit y is equal to 2 minus x, that is 2 minus x whole square minus lower limit y is equal to x square whole square is x power 4 dx. Now, do integration with respect to x 1 by 2 into 2 minus x whole square integration is 2 minus x whole cube by 3 into the inner derivative is minus 1 minus x power 4 integration is x power 5 by 5 between the limits 0 to 1. Substituting the limits of x now, which gives 1 by 2 into the upper limit x is equal to 1, 2 minus 1 is 1, 1 cube is 1, before minus 1 is there, minus 1 by 3 minus 1 by 5. And substituting the lower limit, that is x is equal to 0 minus 2 minus 0 is 2 cube, that is minus 8 by 3 minus 0 power 5 means 0 it is. So, simplify this, you will get the answer that is equal to 16 by 15. So, hence, in this lecture, what we have learned is how to evaluate a double integration over the given region of integration. That means, if the limits are not given, we need to consider the region of integration by means of the given curves. Thereafter, we have two methods, that is either horizontal strip or else vertical strip. We can evaluate this double integration by taking the limits correspondingly and doing the integration with the given order of integration. Thank you.